Good morning, boys and girls. Today we are on page 47 of your student journal, page 47. And our objective today is I will use the relationship between addition and subtraction to find the related facts. Okay, today what we're actually going to be doing is these things that I've already talked about, kind of called fact families. So we've talked about those a little bit in our last few lessons. So let's look at this. So we have our number bond, which we've had in our last few lessons. Remember, our whole is on top, and we have a part and a part, and our two parts go together to equal our whole. Okay, so this says down here what we're going to do today is here's another number bond. Our part equals our whole. And it says, what three numbers are used in these related facts? So what three numbers are in our number bond? We have a 9, a 4, and a 5. And the part equal the whole. So that's called addition. So you could say 4 plus 5 equals 9. Or I could switch my add-ins and say 5 plus 4 equals 9. But the two parts together equal the whole. We could also look at this as subtraction. So we could say our whole, take away one of the parts, equals the other part. Or I could go the opposite direction and say my whole, take away one of the parts, equals the other part. So you heard me call this a fact family when all these numbers are related together. Okay, something that I want you to remember about this is in an addition problem, our whole is our sum. So my sum is 9. But when I look at subtraction problems, remember, our starting number or our minuend is our whole. Okay, so let's remember that when we work on this. Okay. So boys and girls, and you'll also notice the whole is always the largest number. It's always going to be the largest number. Okay, so I'm going to show you what this looks like. Here's my first problem. And they give me an empty number bond, but they give me one equation, okay? So they told me the three numbers that are going to go in my number bond. Now, because this is an addition problem, I know my sum is my whole number. Another thing that I would have known that my sum is the whole number is my whole number has to be the largest number. So if I look at 3, 8, and 11, which one's the largest? Isn't 11 the largest? So your whole number has to be the largest. So then these two must be my parts. So 3 and 8. So 3 plus 8 equals 11. Okay, they want me to write three more equations for this. Well, could I switch my add-ins? Instead of saying 3 plus 8 equals 11, could I say 8 plus 3 equals 11? Yep, that's allowed. It's allowed to switch the order of your add-ins. Okay, now I could also do a subtraction. I could say my whole, take away one part equals the other part. So I could say 11 take away 3 equals 8. Or I could go the opposite direction and say 11, my whole, take away this part equals this part. So in this fact family, you see that we have the same numbers. We always have an 11, 3, and an 8. So 11, 3, 8, 11, 3, 8, 11, 3, 8, 11, 3, 8. So this is what we'd call the fact family. Now again, remember, in the addition problems, my whole is my sum. But in the two subtraction problems, the whole is my starting number or my minuend. Okay, let's look at another one of these. This time, again, they gave me an empty number bond, and then they gave me 13 take away 4 equals 9. So it's a subtraction problem, so I know my starting number is my whole. I also know 13 is my whole because it's the largest number. Okay, so the 4 and the 9 have to be my 2 parts. So they wrote 13 take away 4 equals this 9. So whole take away 1 part equals the other part. So I could go in the opposite direction. I could say 13 take away 9 equals 4. Okay, so in both subtraction problems, my whole is the 13. Okay, we could also do an addition problem. I could say my 2 parts equal my whole. So I could say 4 plus 9 equals 13. And in an addition problem, my whole has to be my sum. Or I could say 9 plus 4 equals 13. I could switch the order of my add-ins. Okay, so boys and girls, let's try some of these together. We are on page 48 of your student journal. Page 48, and here's our first one. Our first one's a little different. You're gonna notice that they didn't give us as many boxes, and I'll show you why. Okay, so what do we see? I see it's a subtraction problem, which means my starting number or my minuend is my whole. How else did I know that the whole was the 12 and not the 6's? Oh, I hope you're saying because the 12 is the largest number. Okay, so if that's my whole, my other 2 numbers must be my parts. So they said 12 take away 6 equals 6. Whole take away part equals the other part. Okay, why do they only have one subtraction though? Because what would happen if I went the opposite? When I say 12 take away 6 equals 6 or 12 take away 6 equals 6, do you see how they would be the same thing, boys and girls? So that's why there's only one subtraction line. Okay, what about an addition? What could we say? Could we say part plus part equals whole? Yep, so what do we have? We have 6 plus 6 equals 12. And in an addition problem, remember the sum is the whole. So part plus part equals whole. And again, even if I switch the order, it's still going to be 6 plus 6. So that's why we only have one subtraction and one addition. Okay, let's do another one together. Okay, this time we have 6 plus 2 equals 8. So which one's going to be the whole? Right away, I know it has to be the largest one, so it's the 8. I also know it was in the 8 because in an addition problem, my whole is my sum. So these 2 must be our parts. So my part plus part equals whole. So 6 plus 2 equals 8. Could we write another addition problem? Yep. Instead of saying 6 plus 2 equals 8, could we say 2 plus 6 equals 8? Let's do that. 2 plus 6 equals 8. Okay, now let's do a subtraction problem. In a subtraction problem, we start with the whole. So we start with 8, and we can say 8 take away 1 part, which is 6, equals the other part. Or we could go 8 take away this part equals this part. So remember, in an addition problem, our whole is our sum, and in subtraction problems, our whole is our starting number or our minuend. Okay, boys and girls, you're going to keep practicing these. Have a good day.